It's time for Math with Mr. Young. Lesson 102, Transversals and Simplifying Equations. Let's begin with a PowerUp. You can use the worksheet provided, or simply pause the video and use a blank sheet of notebook paper to answer the problems on your screen. Go ahead and pause now and resume once you've completed all of the problems in this PowerUp. Okay, today's PowerUp reviews balanced equations with a variable. Before we dive into the answers, I want to point something out which might help you to remember how to solve these kinds of equations that have a variable in them. Let me start with this problem, which is a lot like an order of operations problem from your last lesson's PowerUp. 2 times 3 plus 1. If we were to solve this, we would first do the multiplication. 2 times 3 is 6. Then we would add the 1. And our answer is 7. But what if, instead of starting with all of this information on the left and looking for what goes on the right side of the equal sign, what if instead the problem gave us what goes on the right side of the equal sign and took away one of the numbers on the left side? So now we have 2 times question mark plus 1 equals 7. Of course, we already know the answer, but if we didn't know it, what would we do? Well, we know that when we worked left to right, we followed the order of operations. But when we already have the answer over here, and we need to work backward to find one of the pieces over here, we need to work backward through the order of operations. So what's the last thing we did when we first solved the problem? We added 1. So now let's undo that step. How do you undo addition? You subtract. So subtract 1 from both sides. Plus 1 and minus 1 cancel, which is what we wanted. Then 7 minus 1 is 6. So now we're left with 2 times something equals 6. What was the step we did before the addition in our original problem? That's right, multiplication. So now we undo the multiplication. So we divide by 2. If we have 2 of something and then we divide by 2, what are we left with? Just 1 of that something. When we divide 6 by 2, we get 3. So now we're left with something equals 3. That's the correct answer, remember? This is the process we are doing in our PowerUp. Luckily for us, the PowerUp reminds us which steps we are supposed to do first. But now you know why. When we're trying to find the value of a variable within a problem that we know the answer to, we move backward through the order of operations to find it. So let's try number 1. 2x plus 5 equals 45. Remember, if we knew all the numbers on the left and we're trying to find the answer over here on the right, we'd follow the order of operations. But now we're looking to find the value of this number here in the middle of the problem. So we have to work backward. The 2 operations in this problem are multiplication and addition. Normally, multiplication would come first and addition second. But since we are working backward, we're going to undo the addition part first. To undo addition, we subtract. Subtracting 5 from this side cancels out the 5. Subtracting 5 from this side leaves 40. Now we're left with 2x equals 40, which is the first answer our PowerUp asked for. Now we undo the multiplication. To undo multiplication, we divide. Dividing 2 times x by 2 leaves us with just x. The 2's cancel out. On this side, 40 divided by 2 leaves us with 20. So x equals 20. And that's the second part of our answer. Next up is 3y plus 4 equals 22. This problem looks very similar to the last one. So let's remember the steps. First, we undo the addition part. Subtracting 4 from this side cancels the 4. Subtracting 4 from this side leaves us with 18. There's the first part of our answer. Next, we undo multiplication. Dividing 3y by 3 leaves us with just y. Dividing 18 by 3 leaves us with 6. So we have y equals 6. That's the answer. The next one is 5n minus 3 equals 12. The primary difference with this problem is that it has subtraction here rather than addition. So how do we undo subtraction? We use addition. When we add 3 to this side, we have 5n minus 3 plus 3. The minus 3 and plus 3 cancel out. When we add 3 to this side, we get 15. 5n equals 15 is the first part of our answer. Now we undo the multiplication. To undo 5 times n, we divide by 5. On this side, the 5's cancel. On the other side, 15 divided by 5 is 3. Now we're left with n equals 3. And we're done. 3m minus 7 equals 14. Once again, this problem looks very similar to the last one. So let's do the same thing we did before. Undo the subtraction part by adding 7. 3m minus 7 plus 7 just leaves 3m. 14 plus 7 equals 21. That leaves us with 3m equals 21, the first part of our answer. Now we undo the 3 times m by dividing both sides by 3. 3m divided by 3 leaves m. 21 divided by 3 leaves 7. m equals 7 is our answer. 15 equals 3a minus 6. This problem looks a little bit different than the last one. Last time, we had one number on the right, and it looked something like this here on the left. Don't let this trick you. If you're worried it might trick you, you can go ahead and rewrite the problem the way you're used to, putting the single number over here on the right. Why can we do that? Well, think of it this way. If I tell you that I have something in my hand here, and then I tell you that I have something in this hand too, and that it's the same thing that's in my other hand, then you know that what's in here is equal to what's in here. Does anything change if I switch my hands to the opposite side? No, they're still equal. So let's go ahead and do that for this problem. Switch the sides of the equation, and we'll solve like this. First, let's undo the minus 6 by adding 6 to both sides. The 6's cancel here, and 15 plus 6 equals 21. 3a equals 21 is the first part of our answer. But you'll write it the other way around on your PowerUp. 21 equals 3a, which is the same thing. Now, let's undo the multiplication here. 3a divided by 3 is a. 21 divided by 3 is 7. Now we have a equals 7. Once again, your PowerUp will want you to write it the other way around. 7 equals a. 24 equals 2w plus 6. Once again, this problem is written differently than we're used to. But let's try to solve it this way anyway. The steps are the same. First, let's undo the addition operation by subtracting 6 from both sides. After we cancel the 6's on this side and subtract 6 from 24 on the other side, we're left with 18 equals 2 times w. That's the first part of our answer. Next, we undo the multiplication operation by dividing both sides by 2. 2w divided by 2 is w. 18 divided by 2 is 9. So we're left with 9 equals w. There, that wasn't so bad, was it? Next up, we have negative 2x plus 9 equals 23. The new idea this brings to the table is the negative sign here. But don't let it throw you. Follow the same steps. First, let's undo the addition operation. We subtract 9 from both sides, leaving negative 2x on one side and 14 on the other side. That's part 1. Next, we undo the multiplication operation with division. Can you guess what we divide both sides by? Well, when we had 2x in our very first PowerUp problem, we divided by 2. Here, when we have negative 2x, we divide by negative 2. Once again, x times negative 2 divided by negative 2 lets us cancel out those negative 2's, leaving us with x. On the other side, we divide 14 by negative 2. Remember the rule for multiplying and dividing negatives. If the two numbers have the same sign, the result is positive. If the two numbers have different signs, the result is negative. 14 and negative 2 have opposite signs, therefore the answer will be negative. 14 divided by negative 2 is negative 7. And there's our answer. X equals negative 7. Next problem. 20 minus 3y equals 2. This problem can seem very tricky when you first look at it. But I want you to notice something. How does this problem compare with the previous one we just completed? The problem is actually very similar. Remember, whenever you add two things together, you can switch them around no problem. That's the commutative property, which is a property of addition. 2 plus 3 is the same as 3 plus 2. So if we take the numbers in our previous problem, negative 2x plus 9, we could have switched them around. 9 plus negative 2x. Here's our new problem. Now do you see the similarity? What if we change the 9 plus negative 2x to 9 minus 2x? That means the same thing, doesn't it? Now the two problems look very similar. So let's think about our new problem. What if, instead of writing it as 20 minus 3y, we wrote it as 20 plus negative 3y? Then the 20 and the negative 3y can switch sides using that commutative property. And we're ready to begin the problem. Don't forget that the commutative property only works with addition. You can't switch around the numbers while the operation is subtraction. 3 minus 2 is not the same thing as 2 minus 3. Very different. But if you change the 3 minus 2 to 3 plus negative 2, then when the numbers switch sides, it still works. Okay, back to the problem. Negative 3y plus 20 equals 2. Undo the addition operation by subtracting 20 from both sides. The 20's cancel, and 2 minus 20 is negative 18. Next, undo the multiplication operation by dividing both sides by negative 3. This side cancels everything except y. The other side has negative 18 divided by negative 3. Since both numbers are negative, they have the same sign, the result will be positive. Negative 18 divided by negative 3 is positive 6. We're finished. 1/2 m plus 6 equals 18. First step, undo the addition. Subtract 6 from both sides. Now we have 1/2 times m equals 12. Now we have to undo the multiplication. To do this, we must divide both sides by 1/2. But before we try to go ahead and divide both sides by 1/2, let's remember something about dividing by fractions. If I have a fraction divided by a fraction, I can change the division sign to multiplication if I flip the fraction which follows the division sign upside down. And if you think about it, this makes sense. If I take 1 whole and divide it in 2, I'm left with half. Both of these numbers can be written as fractions. Now apply the method I said before. Change the division sign to multiplication, remembering to flip over the fraction that came after the sign. Now I have that 1 whole, but instead of dividing by 2, I'm multiplying by 1/2. 1/2 of the whole is 1/2. See how that works? Dividing by 2 is the same as multiplying by 1/2. So in our problem up here, we're dividing by 1/2. But we can change the division into multiplication if we flip the fraction on this side of the division sign. So we discovered that dividing by 1/2 is the same as multiplying by 2. So let's do that to both sides of the equation. That's going to be much easier. 2 times 1/2 times m equals just m. 12 times 2 is 24. And there's our answer. 3/4 n minus 12 equals 12. First step, undo the subtraction by adding 12 to both sides. These 12s cancel on this side, and these 12s add together to become 24 on the other side. That's the first part of our answer. Now we must divide both sides by 3/4. We remember from the last problem that dividing by 3/4 is the same as multiplying by 4/3. So we go ahead and do that to both sides. Over here, 4/3 and 3/4 cancel each other out. On the other side, 24 times 4/3 is 96/3, which reduces to 32. And there's our answer. 3y plus 1.5 equals 6. First, undo the addition part by subtracting 1.5 from both sides. That leaves us with 3y equals 4.5. Now, divide both sides by 3. And there's our answer. Y equals 1.5. Finally, 0.5w minus 1.5 equals 4.5. First, undo the subtraction by adding 1.5 to both sides. That leaves us with 0.5w equals 6. Now, divide by 0.5 on both sides. This side cancels out. Now, when you divide by a decimal, you can make it simpler by moving the decimal point over in both the dividend and the divisor. 6 divided by 0.5 is the same as 60 divided by 5. So your answer is 12. W equals 12. We're all done. Here are the answers to your PowerUp once again. Feel free to pause the video and rework any answers you got wrong. Okay, pull out your notes page. Today, we begin by learning about transversals. What is a transversal? Let's see if we can figure it out from the parts of the word. The prefix trans means across. For instance, a transatlantic flight is a flight that goes across the Atlantic Ocean. The Transcontinental Railroad was the railroad built across the continent of North America. Versal shares a root with the word convert, which means to turn about or turn from an old direction to a new one. Also, it shares a root with reverse, which means to turn backward. But it also gets trickier because later, after becoming associated with turning up the soil, this root word also started to mean the lines or furrows dug by a plow. It could also mean a line of writing, or turn a phrase, like in a song or poem, which we often call a verse. So, if you can think about all of that when you see the versal part of the word, you'll begin to understand that a transversal must be a line that has been turned so that it now lies across our other lines. Let's write a definition in our notes. A transversal is a line that intersects one or more other lines in a plane. Hopefully you remember that a plane is any two-dimensional surface, like a piece of paper or your computer screen. Let's see what this looks like. Here are two lines. Now I'm going to turn one of them so that it lies across the other line. Do you see how the lines intersect now? Also, notice that both lines were drawn on the same plane because they were drawn on the same sheet of paper. So, let's check our notes. Does it fit our definition? Well, it's a line, and it does intersect the other line, and the other line is in the same plane. So, yes, this is a transversal. Let's make sure we've grasped this. Are these two lines transversals? Let's check. They are lines. They are on the same plane. But do they intersect? No, they don't. That's because these lines are parallel. However, we can draw a transversal across these parallel lines. This kind of transversal, which crosses two parallel lines, is the kind we're going to look at in more detail today. Let's think about what we already know about this configuration with two parallel lines and a transversal. Can you count how many angles there are here? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 angles. Let's label them with letters so that we have angles A through H. Now, I want you to notice something interesting. Keep in mind that the parallel lines are going the exact same direction. Also keep in mind the direction the transversal is going doesn't change when it crosses one parallel line and then the other. Because of this, the angles formed by the transversal's intersection with this line, angles A, B, C, and D, will have corresponding angles with similar values formed by the transversal's intersection with this parallel line, angles E, F, G, and H. Now, let's look back at our notes page and write a definition. Corresponding angles are angles that lie on the same side of a transversal and are in the same position relative to the two intersected lines. So let's find the corresponding angles. Which angle corresponds to angle A? That would be angle E. It's on the same side of the transversal. And angle A is in the same position relative to the top line that angle E is relative to the bottom line. Now, which angle corresponds to angle B? Hopefully you answered angle F. Once again, the angles are on the same side of the transversal, and each angle stands in the same position relative to the parallel lines. Angle C, then, corresponds with angle G. And D, of course, corresponds with angle H. So that's corresponding angles. Next, let's talk about interior and exterior angles. Which angles shown here do you think would be considered interior? The correct answer is angles C, D, E, and F. Why? Because they are found inside the parallel lines. Things that are inside are interior. Which angles, then, do you suppose are exterior? That's right. Angles A, B, G, and H are exterior because they are outside the parallel lines. Exterior things are always outside. Before we write these definitions in our notes, however, we must combine what we know about interior and exterior with another bit of knowledge about angles. Consider these two lines which intersect each other. You have learned previously that the two angles on the same side of one of these lines are supplementary angles, which means when we add them together, they will equal 180 degrees. But now, instead of looking at angles that are on the same side of one of the lines, I want you to consider the angles that are on opposite sides of both lines. This angle, angle A, is on the opposite side of this angle, angle B. If these lines are indeed straight, then angle A will be exactly the same measurement as angle B. If A is 30 degrees, B will also be 30 degrees. This makes them alternate angles. Alternate angles are on opposite sides of intersecting lines, but have the same measurement. Now, we must combine what we know about alternate angles with what we already know about interior and exterior angles. Let's look at our parallel lines and transversal once more, and see if we can figure this out together. Which angles of the ones shown here are both alternate and exterior? There are two possible right answers. If you said that angle A and angle H are alternate exterior angles, you are correct. Also, if you said that angle B and angle G are alternate exterior angles, you're correct as well. These alternate exterior angles will have the same measurement. Now, which angles here are both alternate and interior? That's right. Angles C and F are alternate interior angles. Also, angles D and E are alternate interior angles. And, once again, alternate interior angles will have the same measurement. Let's write some definitions in our notes. Alternate exterior angles are angles which are on opposite sides of the transversal and are outside of the parallel lines. Go ahead and draw a quick example next to your definition. Draw two parallel lines, a transversal, and then label two alternate exterior angles. Next up, alternate interior angles. Alternate interior angles are angles which are on opposite sides of the transversal and are between the parallel lines. Once again, draw an example in your notes. Let's do an example problem that will utilize our knowledge. Once again, we're looking at parallel lines in a transversal. Go ahead and draw this out, labeling each angle. This time, we're given the measure of angle F. It is 40 degrees. Now, our job is to find the measure of all the other angles. How do we do it? Well, first we know that the angle that corresponds to angle F will have the same measure as angle F. That corresponding angle is angle B. Let's write 40 degrees for angle B. Now, we also know that angle F is an interior angle. So let's find the alternate interior angle. That would be angle C. So we know that angle C also has a measure of 40 degrees. Now, angle B is an exterior angle. So we can use its measurement to find the measure of its alternate exterior angle. That would be angle G. G is also 40 degrees. To get any further, we must remember supplementary angles. Angle E and angle F are on the same line, so their angles are supplementary. That means when added together, they equal 180 degrees. So if angle F is 40 degrees, that means that angle E must be 140 degrees, because 140 plus 40 equals 180. Now, let's use the same method we used before to find the measure of the rest of the angles. The angle which corresponds to angle E is angle A. So A is 140 degrees. The angle which is an alternate interior angle for angle E is angle D. So D is 140 degrees. The alternate exterior angle to angle A is angle H. So H must also be 140 degrees. That's it. We've found all of our angles. All we needed was one angle measurement and the knowledge that these two lines are parallel. Now, before you finish this lesson, your textbook wants us to review combining like terms. You should remember that in algebra there are constant terms and variable terms. Each variable term has a constant part and a variable part. Like terms are those which have the same variable part. Let's do a quick example. 2x plus 3 plus x squared minus 1 plus 2x squared. The first thing I like to do when I see problems like this is to write any missing constant parts of variable terms. What do I mean by that? Look at this x. It stands all by itself. But it can be thought to have an implied 1 beside it. 1 times anything is just itself. So let's write in a 1 here. The same thing holds true for this x squared. So now the equation reads 2x plus 3 plus 1x plus 1x squared minus 1 plus 2x squared. Now, we combine like terms. To do this, circle your first term, 2x. Now circle any like terms, meaning terms with the same variable part. Hopefully you found 1x. Are there any others? No. So let's combine the ones we have. 2x plus 1x is 3x. Let's put that down here. Now put a square around the next term. Find any like terms and put squares around them also. Hopefully you found negative 1. 3 minus 1 is 2. So we can put that down here. Now we can see that all of the terms that are left have the variable part x squared. So let's combine those two. 1x squared plus 2x squared is 3x squared. Now bring that down. Our new equation is 3x plus 2 plus 3x squared. We combined like terms. For extra practice combining like terms, there are several example problems in this lesson of your textbook. Don't forget to write a summary at the bottom of your notes page summarizing what you have learned this lesson. Now it's time to open your textbook. To complete this lesson, start by doing the example problems provided. Try to solve them on your own before you look at the solution and the steps. Once you think you have the correct answer, check your work by walking through the steps, making sure that you arrived at the solution the correct way. Once you are done, you're ready to move on to your homework. See you next time!